Hello guys, in this video I am going to explain the important terminology in programming, which is dynamic memory allocation. This is one program written in C language. Here variable num is declared. It's of integer type. Do you remember in first chapter, very first time when I declared a variable, I wrote in comment, this variable declaration is example of static memory allocation. What does it mean? Int num, when we are saying, that time we are telling to compiler that for this program make arrangement for 4 bytes of data memory. That data is of integer type. You got it? Or shall I repeat? When we declare some variable num of integer type, that means we are trying to tell the compiler that for this program 4 bytes of space is required for integer type of data. You make arrangement for that. This we are telling to compiler. This is nothing but static memory allocation. We are telling the compiler to make arrangement to allocate memory for data in our program. This static memory allocation is also called as compile time memory allocation. So we can show this static memory allocation through diagram. This is int num. In RAM we are showing space allocated for num by the compiler. This space is of 4 bytes, for integer 4 bytes of data is required. Some address that integer will have, let us say that address is 6000. This is static memory allocation. Then what is dynamic memory allocation? Consider same program. We require 4 bytes of space for integer data, but we have not done this declaration. Program started its execution. Still we don't have 4 bytes to store integer type of data. You may be surprised, sir, we require integer in our program and you are not declaring any variable, then how you will proceed in the program? Yes, you are right, but I am going to use dynamic memory allocation in my program. Dynamic memory allocation means runtime memory allocation, getting memory during runtime. I am going to write some code here. That code will provide me 4 bytes of memory during runtime. So this is that block of 4 bytes dynamically allocated for my program. Of course, that code is different in C as well as C++. That we are going to see afterwards. In this video, I am just going to explain you concept of dynamic memory allocation. Alright, so we got 4 bytes where we can store integer type of data. But how to store in that? In case of static memory allocation, this name of that variable, name of that memory location we are using in the program. Using this num, we are able to write data into memory. We are able to read data from memory. But here we don't have any name for those 4 bytes. Then actually when we will get those 4 bytes of block for our program for storage of integer type of data, we will get its address also. That code, whatever code we are going to write in C or C++, that code is going to give us this information where those 4 bytes have been allocated. 6000 means it will be address of first byte of that block. So those 4 bytes will have address 6000, 6001, 6002 and 6003. Right? Okay. So we got address, then tell me what we should do next. Who is going to handle that address? Sir, pointer is going to handle that. Right. So in our program, we will have one pointer. Let us say P. P may have its own address, some 7,000. We are not interested in those values. Those values 7,000, 6,000, I have considered here just for easy understanding of the concept. Alright. So now what we will do? We will let this pointer P point to this block of 4 bytes. So P will contain base address of this block. Now tell me, if pointer P points to this block, this memory location, then what is the name of this memory location? It is star P. That's all. In the program now we are going to use this expression star P to write data into this dynamically allocated memory and to read data from it. I hope you are getting it. So dynamic memory allocation means runtime memory allocation, memory obtained using some code during runtime. Static memory allocation means compile time memory allocation. Compiler is doing that job of allocating memory for data or variables in our program. You may ask, sir, what is use of dynamic memory allocation? This program was okay. Declaration of int num. Why to declare pointers? Why to make the things complicated? Here 4 bytes of memory required for num. Here also these 4 bytes plus some 4 bytes for pointer also. In fact, you require more memory for this program of dynamic memory allocation. You are right. Here I have considered example of single integer. I have considered case of 4 bytes only. But in real life application, imagine you want to store 1000 integers. You are going to require 4000 bytes. Why to use static memory allocation? During runtime, get those 4000 bytes. Using a single pointer, handle that complete data. And one big advantage of dynamic memory allocation is that during runtime only you give back that memory to operating system. It is dynamic memory deallocation. See, if you are getting memory during runtime from operating system, you can give back that memory to operating system during runtime only. So it's efficient use of memory. Whenever you want memory, get from operating system, use it. Once your job is done, once use of that memory is done, give back that memory to operating system. Operating system will use it for some other purpose, for some other program. Isn't it efficient way of using RAM? Actually, this C, C++ are older programming languages. In those languages, we have to explicitly write code to achieve dynamic memory allocation and deallocation. In the latest programming languages like Java, Python, JavaScript, C#, this dynamic memory allocation is inbuilt there. It is done implicitly. It is the way, it is the standard way of memory allocation nowadays. Dynamic memory allocation. You got it? Okay guys, so I will stop here. In next video, I am going to explain the code required for dynamic memory allocation in C++.